Hi, Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Maisarah binti Muhammad Zaki. My matric number is D202211033756. So today I would like to presenting to you the introduction of our geometry project. We focus on analysis of a uniquely designed modern coffee table. In our daily life, furniture is not only made to be useful, but it is also designed to look nice and feel comfortable. So geometry plays a crucial part in creating a furniture, especially in how it is made and built. For this project, we choose to study about a special coffee table which you can find it on the fourth floor of Tuanku Bainun Library at Sultan Idris Educational University. So this particular modern coffee table is placed in the reading lounge surrounded by bookshelf and some bright orange chairs. It is a popular spot among the students who likes to read, relax or having a discussion group. This table has many use, which is you can use it to place your things such as personal item, stationery or books. And it is also used for a light activity such as resting, talking with friends, reading a book, and maybe having a discussion group. This table is not like a normal study table, which is it is made for a casual and comfortable use. The tabletop is circular and has a diameter of 35.7 cm with a surface area of about 112.15 cm square. The bottom part is also circular, which is it is made from a metal ring with a diameter of 21.4 cm and a base area of about 97.23 cm square. The legs of the table are very unique. They are made using triangle and rhombus shape repeated in a cross-like pattern. This design helps make the table strong and also give it a modern and attractive look. So, in this project, we will look at how geometry like shapes, angles, area, and transformation, such as translation and dilation, is used in this table. This shows that mathematics is just not in books and theory, but it is also in the things that we use every day.
Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this section, I will explain the geometrical shape on the coffee table we have chosen, which is located in the arranging area of the Sultan Ahmad Jalil Shah Library at UPSI. This table shows both 2D and 3D geometric features that contributes to its structure and appearance. Let's begin with the 2D shape. The most noticeable 2D shape on the table is the circle. The top surface of the table is a perfect circle with a diameter of 25.7 cm, while the base is also circular, measuring 21.4 cm in diameter. The circular shape provides a balanced appearance and symmetry, making the table visually pleasing and functionally even. Besides circles, triangles also play an important role in the table design. There are two types of triangles that can be observed on the metal frame structure. One type is an isosceles triangle with side length of 11, 11, and 13 cm. The angle of this triangle are 53, 53, and 74 degrees, forming a sharp and stable shape. Another triangle found in the frame also has two equal sides of 11 cm, with angle measuring 55, 57.5 degree, and 67.5 degree. These triangles are arranged around the side of the table, helping to support the top and maintain the table strength. Rhombus shapes are also clearly visible in the metal frame. Each rhombus is formed by combining two adjacent triangles, and all four sides of the rhombus are 11 cm in length. The internal angle of the rhombus are 108 degree and 70 degree, alternating at each other. The repeated rhombus pattern around the frame not only has decorative value, but also strengthens the structure by distributing forces evenly.
Assalamualaikum and hi. In my part, I want to explain about the shape in the concept geometry. Let's restart the isosceles triangle. There are two main triangle types used in the design. The first triangle has two equal side or legs, which is the length of the side is 11 cm. Then the length of the base is 13 cm. The two base angle are each 53 degree, while the top or vertex angle is 74 degree. The perimeter of this triangle is calculated by summation the all side length, giving a total perimeter is 35 cm. To find the area, we apply Heron formula, which using the side and semi-perimeter. The result is approximately 70.23 cm square. The second triangle also has two legs same measure like first triangle, but the base of triangle second is bit short than first triangle, which is the second triangle has length of the base is 9 cm. It has base angle of 67.5 degree and a vertex angle of 45 degree. The perimeter of this triangle is 11 plus 11 plus 9, and we got 31 cm. Using Heron formula again, the area is approximately 45.59 cm square. Next, we move the quadrilateral shape used in the table. The shape has four equal sides of 11 cm and two sets of opposite angle measuring 108 degree and 72 degree. Since all sides are equal and opposite angle are congruent, the shape qualifies as a rhombus, which is also a special type, a parallelogram. The perimeter of the rhombus is calculated as 4 times 11, and we got the 44 cm. For the area, we use this formula. Area equal E square times sin theta, where E is the side length and theta is the angle between the side. Substitution the value, we got area equal 11 square multiply sin 108 degree is equal 115.08. The rhombus also has two diagonals. These diagonals cross the shape and help define its symmetry. For the first diagonal, which connect the opposite acute angle, is calculated using the formula. The line of side term set in bracket 2 minus 2 cos theta, and we substitute the value of side and angle, we get approximately 70.8 cm. Then the second diagonal connecting the obtuse angle, using this formula, length of side term times side in bracket 2 plus 2 cos theta, and then we get approximately 20.90.
Hi everyone, today I will be explaining section 2.3 transformation in motif and pattern based on our group observation of a real object, the table at level 4 of the Tuanku Bainun library UPSI. In geometry, transformation means changing the position, size or direction of a shape without changing its actual structure. One of the most common transformation is translation, where a shape is simply moved from one place to another in a straight line. In design, we often use transformation to create balance, symmetry, and stability. Now, let's look at the leg frame of the table, which I have chosen for this study. The structure uses a repeated combination of rhombus and triangle shape, which together form a strong X-shaped frame. In design terms, a motif is the basic unit. In this case, one rhombus in the center with the triangles above and another below. For example, in my label diagram, the first motif is marked as APM, the same motif repeats as BQN, and so on. The main transformation between this motif is translation. Each motif shifts horizontally from left to right without rotating or flipping. The rhombus move from A to B to C to D, and the triangles also from P to Q to R on top and M to N to O at the bottom. Since the shape, size, and direction stay the same, this is a pure translation, also known as an isometric transformation. But there's another transformation happening called dilation. If we compare the bottom triangle M with the top triangle P, they look like same in shape but different in size. P is clearly larger. This change, same angles, different size, is what we call dilation. I estimate the scale factor to be around 1.44 based on the base length of 9 cm and 13 cm. Now let's move to transformation in patterns. Here, we are looking at how the rhombus and triangles are repeated to form the full leg structure. They are 8 repeated shapes, 4 rhombus in the middle and 3 triangles at the top and bottom. These shapes are placed neatly across the frame, creating a strong and balanced pattern. Again, the transformation used here is translation. Rhombus A is moved to form B and C then D. The same goes for the triangles P to Q to R and M to N to O. All these shapes are aligned in a way that build a clear, uniform structure. This repeated pattern is not only visually balanced but also functionally important. It forms the full leg base that support the round glass top of the table. So the design is not just about aesthetic, it also gives strength and stability. To conclude, this table shows how motif and pattern through translation and dilation can be used in a real-life object, and this connects perfectly with the geometry we have learned in class.
In summary, the modern coffee table at the Tuanku Bainun Library Student Lodge is more than just a furniture. Its circular top and compact size make it perfect for casual reading, discussion, and relaxing. The geometric leg frame featuring repeated rhombus and triangle shapes forming a cross-leg pattern not only adds stability but also enhances its visual appeal. The design beautifully demonstrates fundamental geometric concepts such as perimeter, area, and angle properties, especially through isosceles triangles. The use of transformations like translation, dilation, creates visual balance and different size but similar shapes, resulting a functional and inviting centerpiece for the library. Therefore, through this project, we've gained a deeper understanding of how geometry applies in real life, especially in design and architecture. Analyzing this coffee table shows us how mathematical concepts influence everyday objects and spaces, encouraging us to appreciate the creativity and purpose behind design. Actually, this experience highlights the relevance of geometry in recognizing patterns, solving problems, and enriching our environment.